All right, so let's begin. All right. So I want to appreciate everybody for joining us in this presentation. This has been a long time coming. We've been working on something for the past 2 months now, working on this our brand, Membrane Labs. So now we'd like to share the awesome stuff that we have been working on. What I shared the other time, the video I sent, the video I was playing on loop is actually a project that we worked on recently. It is a portfolio piece. We have several of them, but that was the first one that we used to like kickstart the brand. So now I'll be talking today about bridging science and imagination, the power of biological visualization. Can you guys hear me? Can you all hear me? Hello?
Yeah, we can hear you.
All right. So the topic we are going to be considering concerning our brand is bridging science and imagination, the power of biological visualization. So we're going to be exploring what biomedical visualization is all about, its applications, where it can be used, how it can be improved on, and things like that, and why it's an essential skill in today's world. So now, without wasting much of our time, I would like to begin the presentation now, without wasting much of our time. So yeah, so what we're talking about today is going to be divided into 5 things. We'll talk about our brand, Membrane, as I mentioned earlier. We'll talk about our first portfolio piece, red blood cell in circulation. We'll talk about our pipeline. That's how we create awesome things. What steps do we follow? How do we go about making content? How do we go about making animations as far as medical animation is concerned? How do we go about it? Then also, um, we also give a brief, should I say, a brief overview for our need for collaboration and support, the way we go about messaging or collaborating with people in the health sector, and the need for funding and support from everyone that is currently watching this. So without me wasting much of our time, I'd like to dive into the next agenda. Can you guys still hear me?
Yeah.
All right. So, um, our brand, what's Membrane Labs all about? Membrane Labs is a biomedical visualization studio, and our main task is to transform complex scientific information into something that is clear and something that is concise, that even someone that is not in the medical field can understand, as we shared earlier from the looping video. And what are we working on? We are working on developing cutting-edge visuals to improve clarity and accuracy of medical communication in order to deliver excellent cinematic animations. So that's what we're working on. So the next section here, which is the first item on our table of contents, that one has to do with about our brand. What is this brand all about? And we also want to share our portfolio with you. So a very, very short story. My name is Kunlafe Olasamwe, and I've loved creating things as a child. Um, I have been an avid lover of making stuff with my hands. I love machines. I love creating things like imaginary things. I love bringing my ideas to life. I was inspired by Silas Adekunle when I was leaving secondary school. He is a pioneer of robotic engineering. He studied mechatronics engineering. He loved biology and he was looking for how to merge his love for biology and engineering. For him, it is robotics. For me, it is medicine. I'm merging that with visual storytelling and animation. So, as I said earlier, I said I love biology. And I also like engineering. So my entire journey of animation began when I discovered PowerPoint. So when I discovered PowerPoint, that was when my mind opened to the possibilities of animation for what was possible. As at the time, I had I had been watching some movies, watching a lot of content on animation, and my interest began to peak then. Then I picked up Blender in 2019, and that was when I fell in love with the creative freedom that it provides. So today, as a medical student in OAU, I'm a part 4 medical student in OAU, and I have worked on a lot of projects. I've worked on a lot of projects with friends. One of the projects I worked on was this presentation on a studio about IFEDs. IFEDs is if entrepreneurship department, you know you. So we went ahead and presented an idea for an animated movie, and we went ahead and had critical acclaim in the production. We showcased this character called Ola in the animation, and we had a lot of critical acclaim. People were really, really interested in our work. So I'm just showing and sharing this so that you guys know how passionate we are about animation and medicine, about merging the two worlds together. So apart from that, um, I also want to share the pitch. We presented the pitch, and we had a lot of applause. We even introduced into the fellowship for the 3D studio on campus in IFEDS. Apart from that, also, I've worked on some other projects. I've worked on Notcoin, Notcoin as in the cryptocurrency. Yeah, so I've worked on Notcoin where I designed this for a particular contest, for an animation contest. I worked on this. Then I also worked on another crypto project called Succinct. So this is Succinct. I worked for Succinct. This animation I did for Succinct. Then I can't fit all my portfolio of time. So this is another work I did for Succinct. Then we're not here to talk about previous portfolios. We're here to talk about why biomedical visualization matters. So today I'll be talking about the importance of using 3D to unravel the mysteries of the human body. So why does biomedical visualization matter? It matters because it turns complex, invincible, hard to imagine science into something that we can see, something that we can understand, something that we can remember. In simple terms, it does three things. Number one, it makes the invisible visible. There are parts of the body where lights cannot reach, that we cannot see. Even apart from the fact that they are microscopic, there's parts of the body that are always dark. That it's only when you illuminate them using the power of 3D that you can see them in action. So it also boosts learning and communication. I'm a medical student, so I've experienced not understanding a lot of concepts until I watched animation before I was able to understand them. So it helps us to understand concepts, and it helps patients and doctor to be able to communicate. There could be a particular case, a particular condition that a doctor might want to, how do we now? Like a doctor might want to explain to his patients, but because of the complexity of the medical line, it's better to just show. So it's more like show and tell. Then the next point is that it accelerates medicine research and innovation. So accurate visuals can help some people to plan surgical procedures even before the actual surgery is a thing, in a way like you simulate it before it actually occurs. So it can also help with medical training. It can help with developing drugs using CRISPR technology, things like that. In short, it just bridges the gap. It makes medicine easier to teach, easier to understand, accessible to everybody. So another point I have here is that the greatest scientists are artists as well. This was a quote by Albert Einstein. He said this, and this is actually true from different sciences that we have seen in our day and age. Someone like Leonardo da Vinci, that is known for his famous paintings. Someone like Santiago Ramon Y. Cajal, which everybody has held Cajal before, and also Ernest Haeckel on his images for biological life forms, his accurate image of biological life forms. So what are our aspirations? Now, we create accurate, engaging biomedical visuals that simplify complex concepts. And in the future, we want to become a leading hub that is going to be able to tell cinematic stories and inspire learners and professionals worldwide. Can you guys still hear me?
Yup, yup, yup.
All right. All right. If you are just joining us, I would like to continue. So now I'm going to be introducing to you Membrane Labs. Our tagline is bridging the gap through visualization. So the brand Membrane Labs is not just a fluke. It's a wonderful idea that came when I was in SS1, and it has been shaping itself to become this awesome team since 2020. So here is a post of mine from 2020 where I came up with the first ever iteration of the design. Well, I just knew that my love for understanding how the human body works, and my love for an animation can be merged into two. So from the logo here, we can see that this logo represents two cells stuck in cell division, but they are still connected. So we are bridging the gap through visualization. That's the idea of the logo. And the way I created the logo was that I use metaballs in Blender. Metaballs are like organic kind of primitive organic spheres, organic cylinders, organic toruses. They are primitives that the that a 3D artist can use to create organic life forms, like something like these cells dividing. They are still connected, but they are dividing. So it's like bridging the gap. So now I'm going to hand the microphone over to the branding team. So the branding team is going to take over now. The branding team is going to take over now.
So like I said my name is Michael, and currently I'm a student of OU, and I happen to be the brand designer for Membrane Labs as well. So quickly, I'm going to be running through our brand guideline. I'm going to be talking about the logo, how we come about the logo, and our color palettes. Now, membrane, which is actually one of the simplest but most powerful structures in life. A membrane is not just a wall; it actually connects two sides. It supports life, and it also allows communication, and it also keeps everything in balance. So from that idea, our logo actually shows two cells that is captured in the moment of mitosis, and the point where one cell actually divides to become two. So what does our logo represent? The first thing is that it represents connection. Just like a membrane connects two different environments, our logo also represents how Membrane Labs connects medicine with heart, science with imagination, and complex ideas with human understanding. So we act as a membrane between the two worlds. So it also stands for growth. Mitosis is actually a symbol of development, and it reflects how we grow in skills, in creativity, and the impact we actually want to make. So, and also our logo also stands for continuity. That is, it actually keeps us going through visions. In the same way, our work actually helps knowledge to continue, making it easier for people to learn, to understand, and also to apply these things. So it also stands for the foundation of life. That is, the membrane is actually a basic structure in biology. So our logo reflects this by showing that we work at the core of life, bringing biological concepts into visuals that people can actually feel and understand. So why this logo works is that it naturally connects medicine and heart, and it is also rooted in science, so it is meaningful. And also it is simple, it is clean, and it is also very recognizable. And it also reflects purpose, turning science into visuals that actually feel alive. So this logo isn't just a symbol, it also represents who we are as a brand. So right now I'm going to be going through the logo variation. We use different versions of this logo because it looks clean and professional, and this actually helps with clarity, it helps with contrast, it helps with adaptability, it also helps with consistency as well. So I'm going to be going through the brand typo now. We use three typeface in our brand, and each of these was actually chosen for a specific purpose. For example, the first one is a Poppins. Poppins actually indicates clean, modern, geometric, and precise concepts. So Poppins actually gives the brand a strong scientific feel, and it is actually great for titles and key messages. So our second font we use here is Substance Pro. It is softer and it is more human, and it is also easy to read. And this font actually balances the sharpness of Poppins. That is, it actually makes a long text more comfortable and friendly to read. So, and the third font we use here is the Euro style. Eurosa is actually futuristic, it is structured, and it is bold. And we use this sparingly to actually give a certain visuals a modern and more cinematic look. So together, these fonts actually gives us clarity. They give us professionalism. They give us warmth and also futuristic touch as well. So this actually helps us communicate both science and creativity. So on to the next, which is our color palette. So our color actually helps to express the mood, the energy, and the identity of our brand. And the first color palette we use here is the purple shades. And purple actually stands for imagination, innovation, confidence, and precision. And purple gives a bold, creative, and modern look. And also to the next color, which is the electric blue color. This actually stands for energy, technology, and forward thinking. So these colors add life and movement to the brand. So to the third color, which is a gold, or you can also call it yellowish gold color. So it stands for discovery, brightness, and insight. So gold actually symbolizes clarity. That is when complex ideas finally make sense. And to the last one, which is a white. White actually stands for truth. It stands for simplicity, and it stands for transparency. So white actually keeps our visuals clean, and it also helps the other color to shine as well. So together, this color actually expresses a perfect mix of science, clarity, and creativity, and also imagination. So they make our visual feel both scientific and artistic. So onto our brand usage. Everything in our brand usage actually everything works in harmony. That is, every part of the brand, from the logo to the color to the fonts and the visuals, generally everything works together to actually tell one clear story. And these are the stories. We respect science, we value creativity, we communicate with clarity, we design with purpose, and we also blend fact with emotion. So everything we design actually reflects this goal, to actually turn complex science into visuals that actually heal, that inspires, that educates, and most especially to bridge the gap between science and between arts and medicine, and also reality and imagination. So that would be all from my end. Thank you for listening.
All right. Thank you very much, Michael. We'll be handing the mic over now to Abdullah, which is our web developer, and he has some things to share with us. So the floor is yours now, Abdullah.
Okay, thank you, Ola Samuel. Good evening, everyone. My name is Zadiwan Abdullah. I'm a student of OAU. I'm in animal sciences. I'm the web developer for the Membrane Labs website. Today, I'll be showing you how I went through building the website, things I did, challenges, and every other thing. So I'll be sharing my screen now. Can we all see my screen?
Yes, we can see your screen.
Okay. So the things I'll be discussing. At first, what exactly is Membrane Labs? Our Membrane Labs, our goal is actually to combine creativity and science through modern digital experience. And where the website come in by playing a vital role in expressing our identity, mission, innovation, innovative work, our team, and our team, this thing, what's it called? The work our team produced. My contribution focused on building a functional, modern, and visually aligned platform that communicates who we are to the world. Now, let's take a look at the overview of the website, what I built. The Membrane Labs website was designed to reflect our brand's modern and experimental identity. It features smooth navigation, clear layout, responsive design, and transparent 3D video renders with animations, and it gives a futuristic feel. If we can look at this image here, this is the home page. This is a picture or a screenshot of the home page where we have the Euro section where I made use of a transparent video in the background, same as the section under it. Then if you look at the services page, I also made use of transparent videos. I made use of some animations also. By the time the website is being launched, you will be able to feel everything whenever you visit the website. So the steps I followed while building the website, I studied the brand's mission, the tone and visual direction. We had several calls that were trying to work around the brand identity. Ola Samuel, and the guy that presented before me, Michael. Then I created the website structure where I mapped out the site map, the user flow, the wireframe. Then I went to this thing. Then I designed clean layouts and selected brand aligned fonts and color. I made sure I stayed within the brand color and the brand fonts to ensure consistency. Then I developed each section with responsiveness in mind, because most of the users are actually going to be using their mobile phone. So I made sure it is very responsive across all devices. Then I integrated transparent 3D renders into the design interface. We could not use 3D elements, because using 3D elements, you have to optimize it, and there are a lot of things around using 3D elements raw. So we made use of the alternative. We made use of 3D images, 3D videos, which have transparent backgrounds, by the way. Then I refined the site through multiple feedback rounds with the founder, Ola Samuel. So the major requirement for the website development, the UI UX planning, the front-end development, designing the front-end, what we see, the mobile responsiveness, which is very, very important, media optimization also to make sure the videos are not too large, then following the brand guidelines, then having to host the website and the performance consideration also. So during the design phase, like I mentioned earlier, I made mention that after getting to know what the brand is all about, I had to work on the wireframe before designing it. So by the left, that's the wireframe, while by the right, you have the results after putting in most of the elements. This is for the home page. Then the development phase, building the front-end structure, have to build the front-end structure, styling all the components, adding the interactive elements, those videos and images, ensuring there is fast loading time, which is also very important, and making the site responsive across all devices. So the other thing I would like to talk about is my experience when I was using the transparent 3D video renders. It added futuristic, or why I actually use transparent 3D video. It added futuristic feel to the site. You also feel it too whenever you visit the website. It increased the visual engagement. It required video optimization. It is fun and exciting to integrate, actually. It was more like my first time integrating with transparent video on websites. And it's aligned with the brand's identity. Challenges that I encountered. First, it was large 3D video file sizes. I think Olasam can testify to that. I keep having to go to him that he should help me reduce the size. I have to compress so the website can load faster. And to maintain performance, keeping the consistency with the brand identity, getting smooth mobile interaction, responsive behavior for animations. Sorry. Refinement and final adjustments. In the end, I had to get feedbacks from the team, improve the load speed, visual polish and spacing corrections, testing on mobile and desktop, and adjusting the 3D assets for smooth playback. Thank you all.
All right, thank you for that beautiful presentation, Michael and Abdullah. That's very, very nice. Thank you very much for sharing how your tax for the brand. So now I'm going to be sharing with you how we even created the 3D assets. You've been seeing Abdullah talk about the assets. He even made a joke about how he had to be coming back to me to compress videos here and there. So I'm going to be sharing with you now how our pipeline, how we create 3D assets. So I'm going to be sharing my screen now. Can you guys see my screen?
Yeah, we can.
Yes, you can.
All right. All right. So now that the branding team has spoken, it's time for the 3D team. So now our first portfolio piece, the one I was showing for those of us that joined early, the video that was on loop, is called Red Blood Cell in Circulation. So our brand, this is our first portfolio piece. We have several. We have two others. We have one that I also worked on, but we're not going to share them yet. We're going to like hype it up a little bit before we post them. So we have the red blood cell in circulation portfolio piece. So just like blood cells are very, very important in the body, we decided to go with this portfolio piece to showcase how powerful our techniques are as far as 3D animation is concerned. So this is our creative pipeline. How do we even go about creating 3D animations? First of all, we gather references for scientific accuracy. We 3D model and we 3D texture. We rig, we animate, we simulate. We light our scene, we render, we do post-production. We use some particular software tools, and we get feedback from experts based on what we have created. So if any of these words are very new to you, don't worry about that. We're going to do our best to like make everybody follow along with what we are saying. So now, since I'm a member of the 3D team, I'll be handing over to myself. After I speak, Bukumi and David are going to come on board and share the way they created their 3D assets. So first of all, we gather references. What are references? References are images that are showcasing what we are trying to create. We gather references from apps like Pinterest. Then we organize them in another app called PureRef. So we will make sure we organize them in such a way that everything that we're doing is accurate. As you can see here, we have red blood cells, we have pathogens, we have blood vessels, white blood cells, like that. So we make sure we organize them. Everything that we're working on, can see anatomy over here. We gathered references to just make sure that everything is in line. Everything is in line with what we are trying to work with. Can you guys still hear me?
Yes, we can hear you.
Yeah, and can you see my screen, please?
Yeah.
Yes.
All right, so on to the next thing on our pipeline is 3D modeling and texturing. So what exactly is 3D modeling? 3D modeling is the process of like making an object in 3D space. I'm not going to the technicalities of it because of our time, but 3D modeling, from these GIFs that you can see here, it is a way of creating objects in a 3D space. As you can see, somebody is cutting up a cube, inserting a cube, extruding a cube. And also, we also have 3D sculpting, which is a form of 3D modeling. But this one works with dealing with digital clay. As we can see here, this guy pulling on this guy's face, as you can see. So sculpting is a form of 3D modeling. And 3D modeling just means making an object in a 3D space. Now, what is 3D texturing? 3D texturing is the next step. After you make something, you would like to color it, right? So adding color or texture is called 3D texturing, which is a way of making your created object be able to exist in the 3D space. Because once you give it texture or color, it will come alive. As you can see here, this is a 3D texture. This person textured it. This is something that they call a node group. This is a node group, or now the person textured it. We won't go into the technicalities of this, but that's what 3D texturing is all about. And next, we'll go into how we employ 3D modeling and texturing in our own portfolio piece. So this is a model that we worked on. We actually did a combination of 3D modeling and 3D sculpting to be able to achieve the singlets I can see here and the human arm. We only had to model half of the arm because we wanted to optimize the project. We did not want to have any issues. And this is our material stack. If you are a nerd and maybe you're interested in learning how we did all this, you can always drop a message or drop a question in the comment section. Then another project that we employed modeling and texturing for, at least for my own section of the portfolio, was hepatocyte and sinusoids. These are cells of the liver. Now, from our reference, we gather the reference. Let me show you the reference pretty fast. So this is the reference. This is the reference for the hepatocytes over here. This is the reference that we used. So this reference, and this is what we ended up creating based on the reference. This is the hepatocyte and sinusoid. So we modeled it, we textured it, we use some modifiers. Modifiers are like some operations that will make our work faster. Then another one I worked on was coffer cell. We also modeled it, but it is a more primitive kind of model. We use a lot of modifiers for it. Modifiers as in operations that make work faster, as I said earlier. So we used a UV sphere or a circle and this prong. Then we used a modifier, as I said earlier, to just scatter it around the objects like this. Then this is the texture stack that gives it the color. Then another thing I worked on is cephalic vein. If you watch the introductory portfolio piece, you see cephalic vein. This is how we created it. We used curves. Curves is like a kind of modeling also, but using control points is very, very fast. So we use curves, designed the node stack to give it this shader. And this one, this is the viscera, or the viscera of the abdominal and thoracic cavity. This one was gotten from an open source atlas of anatomy called Z Anatomy. Then the next thing on our agenda now is rigging, animation, and simulation. So if you are not new to what these terminologies mean, I will just quickly run through them as fast as I can because of our time. So what is rigging? Rigging is the process of giving a 3D model skeleton so that it can move. That's basically what it's about. It is more complex than that. From this video I'm playing over here, you can see, let me take it back pretty quick. From this video I'm playing over here, you can see the process of me moving the bones around this character, moving it about, bending it about. So rigging is just adding bones so that your 3D object can move. From this guy flexing his knee over here, you can see that bending the knee, these bones that are bending the knee are called a rig. So that's what rigging is all about. This is a bone. My version is a bit more advanced, but this is a more primitive outlook on what bones look like. Then what is animation? After you rig your character, you want them to move, right? So animation is the process of making them move over time. So from this example over here, we can see that moving the bone at set times makes this gun fire. We can see over here that this ball hitting this stack of dominoes makes it fall, right? So that's what animation is all about. It doesn't even have to be only with a rig, with a skeleton that you can animate. You can even animate something like this without using a skeleton. Now, the final thing here is simulation. What is simulation? Simulation is the process of like creating real-world physics, real-world events in a 3D space, in the sense that you don't have to animate everything by hand every time. There are some complex things that you cannot animate. For instance, rainfall, Rainfall, imagine animating all the individual droplets of rain. It's something that you can use a simulation for. So the way simulations work is that to calculate gravity, calculate stuff like friction, calculate things like behavior of that object in the real world, and try and replicate it in 3D space. So now, how do we employ these three techniques in our animation? First of all, we have our reference over here. This is a reference of me flexing my arm. So I've recorded a video of myself flexing my arm to try and replicate it in animation. After flexing my arm, the character that was already modeled and textured and rigged, it's just a matter of me moving it in accordance to the time frame. As you can see here, you can see me flex this guy's arm. See me flex and bend his wrists and control and rotate his arm, his fingers, his digits, all those things. I can see over here that we try to replicate veins. He's a veiny and muscular guy. Then apart from that, we also animated some other things. For instance, here you can see us animating this cell. This cell has a lot of spikes over it. So we animated it using a modifier. So if you don't understand what a modifier is, you don't. Okay. All right. So What I'm just trying to say over here is that it's not only with bones or skeleton that you can animate, you can also use a modifier. You can also see here that we rigged this red blood cell, moving it about to be able to behave the way we want it to behave. Also, this cell, this is a platelet. We also rigged it and move it the way we want it to move. Now, the next thing on the agenda here is the results of the animation. After all this tweaking and tweaking, we're able to come up with the animation. So after all the tweaking and tweaking of the bones, we're able to come up with the animation. Now, for the next agenda, the next thing on the agenda is simulation. I just said before that there are some things that you cannot animate by hand, but you have to like make them automatic. So something like rainfall was the example that I gave. So something like this kind of behavior of red blood cells moving in a blood vessel, we cannot animate everything by hand. It would be too tedious, so we simulated it. Simulations are very intensive on computers, but we're able to pull it off by using a particle system. So we use the particle system to simulate different particles to follow a curved object. So now I want to move on to the next item on our pipeline, which is lighting and rendering. What is lighting? As the name suggests now, lighting is a process of placing lights in your 3D scene to make it pop, to make it feel alive. Is a way of bringing your objects to life. Modeling and texturing is not enough. You have to be able to light your scene properly. The next thing on the agenda is rendering. What is rendering? After you create everything in 3D space, looking at it is not enough. You want to be able to bring it out, like exporting it. That's rendering. So rendering is exporting your 3D model to become a 2D video, something that you can play back or an image. So after you have already properly modeled, textured, and lit up your scene, it's now time for you to rendering it in the sense that you make it a video or an image. Now, from these examples that we can see here, you can see that this this is the before for my cursor. This is before. This is how it looks like without any text, without any rendering. Now, finally, this is how it looks like after. Now, this is a collage of what lighting and rendering did to our scene. This is a properly lit blood vessel. As you can see, this is a blood vessel here that is lit up properly. Where you can see red blood cells that are lit up. Where you can see the lighting is so good that it even captures the sweat on this guy's arm. Where you can see the way we lit up this scene of the silhouette of copper cell, the human arm, hepatocyte and sinusoid. You know, before it didn't look this good before, but after we listed and rendered it, it looked better. Then over here we can see other cells that my colleagues are going to talk about very soon. You can also see this red blood cell. You can see this macrophage. Yeah. So on to the next agenda on the 3D pipeline, which is post-production. So what does it mean to post-produce? Post-production is when you are done rendering all your individual shots, you want to combine them together, right, into a video. Yeah. So when you compile them together, you color correct, you compose it. Compose it means is a kind of color correction, but it is more precise. You add visual effects, you edit the sound, you do sound design, then you finally edit it and make it a full-fledged video. So these are the shots that we rendered in sequence from sequence 1 to 8. Then we merge them together, design the sound, add the visual effects, and finally did the final edits. So what are the software tools that we use? What exactly do we use to achieve this that we usually use to bring our ideas to life? We use these softwares. We use Miller Notes. Miller Notes is a program for planning. Basically, it's for creating mood boards. Pinterest, we use that to gather references. PureRef, we use that one to organize all our references into a stack that we can share and follow. We use Blender, another software, for our major bulk of our work. It's a very free software. It's a free software and it's free for life. Shout out to Tom Rosendahl. He's a very great man. He's a founder of Blender. We release this powerful tool for free. We also use Substance Painter, which is by Adobe. And what Substance Painter does, as the name suggests, is to paint, basically, but it does more complex painting because it is only for texturing. So it is very great for texturing, but Blender is a jack of all trades. Next we have Houdini, which we use for simulations and effects. We have Rokoko. We didn't use Rococo for this project, because Rococo is a motion capture program, and our animation was not that complex for motion capture, so we just animated it by hand. But we have experience with Rococo. Photoshop, we use Photoshop a lot. We use it to edit our textures. We use it to design our brand guidelines. Basically, anything that is 2D related, we use Photoshop. Then DaVinci Resolve, this is our video editing software that I use to for post-production. We use that to for post-production. We use to color correct. We use to polish our renders by compositing. Now, I'm going to be handing the mic over to the rest of the 3D team. I would like to call on Bukumi to give us a rendition of his contribution and everything that he worked on the team. So I'm going to stop sharing my screen now, and I'll open the floor for Bukumi.
Hello, everyone. I'm Bukumi, and I was one of the 3D artists that worked on the pipeline also. And I'm here to basically explain, how I went about it, how I went about my work. Episode 4.
All right, Bukumi, you can continue.
Okay, so the first model that I worked on was the first model I worked on. Please, could you move to the first model? Last one. All right, yeah. So the first model I worked on was the lymphocytes, and basically this lymphocyte is a type of white blood cell that helps the body. And the way it was made with two models that I joined into one to help it look basically realistic. Okay, the lymphocyte was made with a sphere and the objects that we can see on the screen. Olasan, could you please go to the lymphocyte?
Yeah, I'm on the lymphocyte now.
We can't see your screen. Sorry.
Okay, can you guys see my screen now?
Yeah, we can see it now.
Okay.
All right.
I can't see it, but I guess that's just me. Okay, so the lymphocyte was made with two models, which was the sphere and the thread-like model that you see. But I also used the particle system in order to make the bodies that basically came out of it. All right, so the lymphocyte is a primitive 3D sphere, while the spike is an instance from the particle system. Basically, it was optimized to favor performance, because if I had used one each of the thread-like model, it would have been very tasking for the computer. So it's better to use a particle system whereby the thread-like models make random movements, and it makes the lymphocytes look really realistic and better in real time. So that was how the lymphocyte was made. And the shader, this was the shader pack. The shader pack is also shown in the slide. And we'll move on to the next one, the neutrophil. Now, in the neutrophil, there was the outer layer and also the inside layer. All right, so the outer layer was also made by a sphere, but I used the could you please move to the neutrophil?
All right, I'm on the neutrophil now.
All right, thank you. So it was basically made with two models joined as one. All right, so the second model was parented to the first model, and the first model was was the sphere that we see, and basically the sphere that we see was made transparent, so the inner model will show. It's basically the neutrophil is basically one that helps the body engulf, bacteria and stuff to help the body um move, to help the body work well, basically. All right, so it was created with sphere, and you can see those things that connect the inside of the inside layer of the neutrophil. Those were planes, basically. Those were planes or rectangles, sorry, cones that basically help connect the three. Those were cones that I used to connect the three, and it worked. Basically, it looks like a real life neutrophil that engulfs bacteria in the body to make us, to help with our healthy living, basically. We'll move on to the red blood cell. The red blood cell, here we see an optimized 3D model of the exterior of the red blood cell. All right, now you can see in this red blood cell, when it was textured, I had to add subsurface scattering. You can see that there was light. When light is shown in the red blood cell, you can see the inside. The inside of the red blood cell shows subsurface scattering, because that's how it is really in basically the exterior view. That's how it looks real life. All right, so there were a lot of materials that I needed to add, because it's also a bit scaly. The red blood cell is also a bit scaly. It's not just smooth in nature, right? So there were a lot of materials that I needed to add in order to get the desired texture that I wanted. And I think I'm happy with what I got. But basically, the red blood cell was basically made from a sphere which was squished together. Now, if you can see the second image in the before, the second image was basically it was squished together, and it has this curved pattern that I sculpted it a little bit in order to get that curved pattern for the red blood cell. And I believe it basically looks really good, and the texturing also works because it shows that there's blood inside with the subsurface scattering, and it looks basically realistic, and that is what we were going for in this project. Now the shader materials are also there to see how it was made. Now we move on to the teeth and the gums. Now for the teeth and the gums, for the teeth, tongue and gums, for the tongue, it was basically planes that are used for the tongue. Tongue is pretty easy to make, so it was planes that I used. I just lined it up in the teeth, then I solidified it, and I gave it subsurface scattering. It was as simple as that, basically. All right, so the tongue was one of the easiest model made because it was pretty straightforward. But the teeth itself, not the gums now, the teeth was one of the most tasking, because the amount of detail that was needed on the teeth, was a lot. It was a lot. And I used, what do we call it? I used Dine Topo to get as much detail as I could. The details was sculpted, not model. It was basically sculpted on the each of the teeth. We have 32. It was sculpted on each of the teeth, basically. So in order to get an optimized work, not basically making all of them look alike, because the front two teeth basically look different than the last 4 or 5, so I had to do them each one by one in order to get the desired result. Basically the front two are bigger, all right, and longer, and they are more sharp than the last 4 or 5. So I had to sculpt each of them. And the gums also they needed a lot of attention, because I needed to get the right place where the teeth comes out of the gum, and for it to look as realistic as possible. All right, and I think I did just that with the gums and the teeth. All right, so for the teeth, I sculpted a lot of detail on the teeth in order to that's for well, I think we're going to see that in our next portfolio. We haven't released that for now. When we've gotten a lot of buzz around it, we are going to release it. But for the teeth, a lot of detail was put into each and every one of the teeth just to get a desired result. And I think Olasam, our 3D generalist, it did justice to the animation that was on it. Okay, so the teeth, the gums, and the tongue, that's done. And lastly, there was a human silhouette that I basically just formed from what do they call it? Vertex, yeah, vertex. I basically traced a human silhouette. All right, and we got that human silhouette because we needed the human silhouette in the animation um for the first portfolio piece which we showed. So the silhouette was needed in order to um okay, so the silhouette was needed in order to show what happens in the human body. It was from the human body to the arm, then inside the arm, we see what's going on in our daily lives when we are gymming or when we are exercising and stuff like that. So it was really important for us to see, to see what was going on in the human body. And the human silhouette was by far the easiest model made. So I think that is all. We've spoken on firstly the lymphocytes, and we said that it was made by a sphere and a thread-like model, which was added to the sphere through the particle system. Then we moved on to the neutrophil, which was basically two in one. It was basically two in one, the inner chambers and the outer. And the inner was made with spheres and basically a cylinder joining the three spheres, and the outer was made transparent so this inner would show. The red blood cell, that was made by a sphere also, and was a bit of sculpting so the side shows, the inside curve of the red blood cell shows, and also in the texture the subsurface scattering to show that blood is actually in the red blood cell. And the teeth, gums, and the tongue, basically the tongue was not sculpted, it was actually modeled, but every other thing in the teeth and the gums were sculpted bit by bit, and the human silhouette. So thank you guys for listening to me, and I would pass it on to Skylight from here. Thank you so much.
All right. Thank you for that beautiful presentation. I'll be handing the floor over to Skylight to continue this presentation and talk about what you worked on for the team. So I'll be turning off my mic now.
All right, so good evening, everyone. My name is Skylight, and that's my work name. My name is Dave, actually, and I worked on a few projects concerning our portfolio and my contribution to membrane labs. And my first is the platelets. Although I am not a medically inclined person, and I am only intrigued in mixing medical line with artwork and
Hello, your microphone is muted, Abby. We cannot hear you, David.
so I worked on platelets. Platelets are like tiny colorless, disc-shaped fragment of cells that circulates in our body. They help us That was stop our body from bleeding, and they are kind of like a blood vessels that support the body metabolism whenever we get injured. They're basically like tiny red blood cells, but kind of different. It's like call them an aspect of red blood cells. And although modeling the platelets was a bit challenging to me because I focus mainly on art surface modeling or models that have angles and a defined shape, not organic models such as modeling humans and all these microorganisms. So I followed a couple of references, and I finally created this after tons of trials and errors. I think I made this first plate like I think I had like 5 trials from starting all over afresh, over and over again. Then concerning the material was a bit complex. Figuring out different ways to simulate a perfect red blood cells and having it look like the skin of I'm mostly used to metallic surfaces, plastic surfaces, and all these ordinary textures that are easy to make. Unlike organic stuff like skins, pores. If you notice the texture, it has a little bit of tiny, tiny, tiny pores, like bones on it. Before I could get the normals and the displacement values for them, it was a bit challenging. And then moving on to the next. Uh, Let me talk about the wireframe mode. The wireframe mode, I like my workflow to be a bit, I like having my workflow to be seamless concerning the wireframe mode. Everything to be in quads instead of ordinary end guns and having trigons in it. And as you can notice, everything is in organic shape. There isn't any sharp edges, any sharp corners, any flip normals, yeah, in my work. So, and then moving on to my next model, I have the macrophage. I know nothing, or I know very little about macrophage, and this was the most difficult model that I had to work on during this entire project, as I had a lot of trials and error, even more than the platelet. I think I worked on this like 8 times over and over again, and even this one that I'm presenting right now is as a result of different mistakes combined together. This is not just a single model. It is like I inserted multiple models into each other. As you can, if you view in into the wireframe mode, you see there are actually two models overlapping each other. Yeah, there are actually two models overlapping each other. If you look within, you will find a ball with spikes shooting out. I could not find a way to make a single model that will encompass the cylinders and the spiky spears extruding out from the same point. So I had to like duplicate a sphere first because I am not used to working on working on organic materials. I mostly use spheres and cubes for my work. So figuring the way how to model something that is extremely spherical to something that is organic is kind of like it's kind of like a toll on my brain. So I had to figure out a way to extrude different points and then create an extraction. And okay, I had to from the spear I had to make different loop cuts first, then extrude them, and then duplicate the same model, shrink it, then extrude those same point that I have extruded out, and then shape the tips to be like sphere. And each of them, it was done by hand because I had to like take time working on each of the spheres. And the materials was a bit annoying to work on. As you can notice in the wireframe mode, the tips of those cylindrical extrusions, there's kind of like a partition. You can find the partition at the tip of every one of them. That was a difficult task for me to work on concerning the material because I was done with the entire model before I discovered that okay, the tip of the macrophage is of a different texture from the rest of the body, and then I had to start figuring out a way I can how can I put it, mass work the loop cuts across all the entire extrusion of the cylinders. And then going on to the material. The material here is just simply, they're all simply plastic material that I have already made down already. And I just tweaked some, because I could not even figure out a way to create an afresh material from the reference I was looking at. The materials on the reference, they were very, very complex to work on. So I had to like, what's the word to use? I had to improvise on the spot. So I looked for one of my plastic materials and I tweaked it. You know, there's a way I do my work that I can make materials look exactly the way I want them to look like. And added subsurface division to them and make them shine a little bit. And I was even telling the teammate that when he's working on it, that I made the materials to be very, very modifiable. So if he feels that my material is not close enough to the reference or it's not looking realistically enough, that he should feel free to adjust it to what is right. Because, like I said, I am not into the medical line fully, totally. I just like the artistic aspect of it. And finally, the last model I worked on, this was the easiest model so far because this is basically a capsule. Just it didn't take me enough time, and the tendrils on the capsules are also very, very easy because I used a modifier for it. And then after using the modifier for them, I converted them to from um from curve to mesh, then give it depth and extrusion. That's how I came across this. And you also look at the wireframe mode, ignoring the wireframe of the tendrils, because that's how tendrils are always like when you convert a mesh, a curves to mesh, the polygons and the quadrants, they are always much. But concerning the capsule is very, very easy. Doesn't really have much um doesn't really have much edges and vertices because I like working with projects that will not take a toll on computers because I know I'm not the only one using my computer and I also have other people too. So it more makes sense if I have to model something and my other teammates won't be able to open it. So and the material was also easy to get because I use fresh now here. I don't know explaining the material will go too far. So I think I have to skip it a bit. And then I made some props concerning the normal portfolio videos, the introduction videos. I modeled these dumbbells for the team, and they're also very easy. Also, to flaunt my workflow, if you check the wireframe mode, everything is as dope as it looks. Yeah, yeah, and the materials are very, very easy. They are already made material that I have already on my laptop, and I think that was all about my project. I'm very sorry if I'm not good at public speaking, so I think this is where my project ends. Thank you very much.
All right, thank you very much, David. That was a very awesome presentation, and I like the way you flaunted your wireframes. I cannot share my wireframe because most of what I worked on was okay. Well, I shared some of my wireframe share, but then yours are very, very clean. And thank you for improvising and putting up with the models that we asked to design, and they turned out very, very beautifully. So now I will be handing the microphone over to the next speaker, which is going to be David. So David is going to be speaking now. Well, I'll be sharing my screen. So let me quickly open up his presentation. All right. Another quick reminder, if you have any questions for us, you can start dropping them on the general chats, and we'll have a section for questions after the presentation. So I'll be handing the mic over to David Ade, my friend. We are close colleagues. He's also a medical student and is a member of the scouting team. So I'll leave the floor to you now, David. I'll be turning off my mic.
All right. Good evening, everybody. I'm David Ade. I'm a fourth year medical student of the College of Health Sciences, and I am a member of the scouting team for the project. So, membrane labs, we talked about more membrane labs. We usually talk about what we do, and essentially, in one statement, we are pushing the power of biomedical visualization. On to the next slide. So, while then are we pushing the power of biomedical visualization? When you hear biomedical visualization, you're like, okay, we can visualize biomedical concepts, but like, how is this? Like, what are the opportunities in this? Well, from a medical student's point of view, having visuals when you are reading about medical concepts is such a lifesaver, especially in courses like embryology, where you need to figure out, okay, how exactly is it folding? Or there's a saying that a picture is worth more than 1,000 words. And when you can see it, it's like you can put a face to the name. So biomedical visualization impact healthcare education, not just healthcare education, it also impact marketing and patient care. Because imagine a scenario where you're going in for surgery and the surgeon can show you a visual of everything that they are going to be doing. It's going to be life changing, and you're going to feel like you have an idea of what goes into the medical decision making process. So these are just a few of the numerous opportunities that are out there in the medical field, in our education, in healthcare delivery, in marketing, and then also in research. And what we can think about is education at the biological level, even in your regular biology classes. It is going to like make your work so much easier. Then so moving on to the next slide. So our team. Well, I'm not the only one on the scouting team, but there's Mary and we have other members on the scouting team. Moving on. So we've talked about the opportunities in 3D now, in education and training. Well, a lot of times in medical school, there are times that you just need to see certain things, especially in courses like anatomy, which are very visual. And while we have 3D atlases for gross anatomy, histology is quite hard to wrap your head around because of there are just no good 3D renditions of histological concepts. I remember it's 200 that was reading histology and it felt like I was just losing my mind and things for history and bro. So this product is going to revolutionize medical education everywhere across medical schools in the country or globally, because we're not just going to be making like we're going to be bringing to life medical concepts, and this is going to help foster education in the doctors of tomorrow. Next slide. It's also helping patient communication, like we have talked about. Your doctors will be able to have a model ready to show to you what it is that they have planned out in the medical decision-making process. If it's a tumor resection or if it is just administration of drugs, it can show you the mechanisms. So this will help for clearer patient communication as the era of top-down medicine has come, it has gone. Medicine today requires the patient to have a full understanding of what it is going to be done to their body to eradicate the disease. At the end of the day, the patient is the ultimate stakeholder. Moving on to the next slide. And it also help in in marketing and in pharmaceutical industry, marketing and pharma as well. You'll be able to show when we expand projects, you can be able to talk about drug mechanics, how drugs work and the interact with certain biochemical components of the cells. So you can see that this is a revolutionary project and they are really glad that you are a part of this. Next slide. So, as you know, this is a passion project and it is a startup. So, this is a call to you if you want to invest in membrane labs or be our client. Being our clients could be that, let's say you're a medical school and you need renditions for TCA for some of your courses, we have that for you. And you could also invest in the company because this is growing at an alarming rate. I remember back in 2023, looking for an anatomy atlas online and it was so hard to find one. And now, fast forward to late 2025, going to 2026, there are so many atlases springing up just covering growth. So it is a growing market. Next slide. So, well, plant membrane labs, like I have explained, the market is valued at 493 million in 2023 and is projected to reach about 2.4 billion by 2032. From atlases from Catfish Studio, Biodigital, Visible Body Shield, Complete Anatomy, Kaplan, like there are so many 3D renditions coming out because people are starting to understand the importance of visualization in medical education. I'll never forget how this used to kind of medical visual just simplified embryology, not because he wasn't saying the exact same things that was in the embryology textbooks, but because we could actually put a diagram to what we were reading and it just made life so much easier. So investing in us with us membrane labs, you can guarantee a good return for your money because the market is there. There is the demand for 3D visualization in medical concept. Next slide. Our services, 3D modeling and texturing. We make high detail models of cells, organs, and devices. We also do rigging and animation. And rest assured that the scientific accuracy is going to be top notch. We are medical students doing this. I mean, it is what we are studying that we are creating. So there is no cause for alarm or to question the integrity of the scientific accuracy. I, for one, can access to a volume of textbooks that we have to read some of these, but our services are top notch. Next slide. And also, if you're looking to partner with us, networking and collaborative, if you're a medical institution that you need educational content, if you're a research faculty and you need visualization for your research project, if you're an investor and you want to see our vision bringing science and art, and if you're just a 3D artist and you want to apply your skills to be part of this project, we are here for you to collaborate with you and to network with you and to grow this project Membrane Labs to new heights. The next slide. So thank you for your time. And if you have any questions, like our founder and chief said, you can drop it in the chat. We look forward to hearing from you and working with you. Thank you. And once again, I am David Adam.
Thank you very much for that rendition. Can you guys hear me?
Yeah, we can hear you. So,
All right. So thank you very much for that presentation, David. So as I said, this is a passion project, as we said earlier, but how that we do this now, this is a passion project, but at the end of the day, money is going to come out of this. It's not just a passion project for passion project's sake. We are passionate about what we are doing. We're medical students. Some of us are not, but those of us that are not medical students are passionate about animation. So hand join in hand. It's a very, very great initiative, and we would like you to be a part of this. You have seen the bets of this studio, and as time goes by, the dreams we have are very, very great. And as time goes by, we are going to like achieve a lot of things in the medical animation industry, because number one, it is undertapped. A lot of animators are not in the medical line. A lot of people in the medical line are not interested in animation. So finding out that we actually bridge the gap is actually very, 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 very great. So now I'm going to be sharing my screen to be continue the presentation. Let me share my screen pretty fast. Can you guys see my screen?
yeah, can.
All right. So the scouting team has spoken already. So I would like to talk about where we are based. We are all students of OAU. We are friends of friends of friends of friends of friends of friends with interests, with aligning interests, with aligning skills, and all of us have come together to establish this brand. I told you earlier that it was a vision from when I was in secondary school, so it has been a long time coming. Even the name was coined in 2020. So we are based in OAU. We operate remotely for now, but as time goes by, we are going to establish a physical studio. So now I'd like you to meet the faces behind the beautiful work that you have seen so far. First, that's me. My name is Kumlafe Ola Samuel, and I'm the founder of Membrane Labs. I'm the lead project designer, I'm the lead 3D artist, I'm a 3D generalist, and creating animation is my passion. Together with medicine, I have been in love with animation for as long as I can remember. Since as far back as 2019, I started actually actively working on animations after secondary school, and I love to understand how the body works. So naturally, that gave rise to this. So I'm going to hand the mic over now to Michael to quickly talk about himself.
All right, thank you so much, sir. Nothing much. My name is Michael Adepoju, and currently I'm a student at the Obafemi Awolowo University. So alongside with that, I'm also a brand identity designer. I've been a brand identity designer for, I think this should be my 5th year. Yeah, this should be my 5th year now. So, and medicine and tech, these are the two things I've always been passionate about. And I've been looking for a way, because some people will tell me that there's no way you can combine, you can be a doctor, like, and at the same time be a tech. But Membrane Labs are actually like brings clarity to that, like how you can relate medicine and like how you can combine tech and medicine and still impact life with that. So it's really honor or like believe that the sky is just a starting point for us that join this meeting. Thank you.
Right, thank you very much, Michael. So you can see that we are all passionate about this. I'm going to be going to the next page where David, I'm going to be handing over the mic to David to tell us about himself. Just one or two words. David, over to you.
Um, okay. I'm David. I'm a 4th-year medical student at the Obafemi Awolowo University, and I've always been passionate about medicine for a very long time, and I've also been passionate about the power of tech in medicine. I'm a 4th-year medical student. I'm a data analyst and I'm a digital marketer. I have experience, I have about 3 years of experience in digital marketing and 2 years of experience as a data analyst. So I've always been passionate about bridging the world of medicine with technology and innovation. And here at Membrane Labs, we do just that. So I'm something great. Thank you.
All right, thank you very much. I'm the mic over to Abdullah to say one or two things about himself. Okay, I don't think Abdullah is with us, but Abdullah has been my friend since way back, since I think 2021, and he's a web developer. He's passionate about what he does. He's very very he's a very from the work that I have seen. He's a very very versatile web developer, and he has a lot of nice portfolio under his belt. So I'm going to be going to the next slide, where I'm going to hand over the mic to Bukumi to say one or two things about himself. And also, if you would like to connect with any of us, you can just drop a message on the in-call messages. So Bukumi, over to you. I don't think Bukumi is also with us. Okay. I think Bukumi, are you there? All right. So Bukumi is not also with us. It's probably maybe his mic is muted. So I met Bukumi in 100 level, met him in 100 level in Angola Hall, and it was actually through me that he started 3D animation. He's a law student, but he part 4 law students, and just that just to show you that the possibilities that two interests can coincide. Definitely, when started an animation, I remember when people were saying to merge animation with medicine, and it's not easy. This, that, this, that, this, that, and you can see that people across different fields are able to merge these two together, and these two words are coexisting peacefully. So I'll be handing the mic over to David. If David is with us, he would like to say one or two things about himself and about maybe we can just catch up with David. Okay, so I'll mute my mic now.
Good evening, everyone. My name is David. My work name is Skylight, and my journey into 3D modeling started 4 years ago, and I started as a result of wanting to delve into 3D modeling from 2D. I was initially a 2D artist when I started, and I got my first laptop. That was 4 years ago. So, and the reason why I even got it was due to 3D modeling, and the journey so far has been good and it has been smooth. And today I can call myself a partial professional when it comes to 3D modeling. I think that's one. And the reason why I am doing this is, although I have no interest in focusing on the medical line, I only care about the artistic aspect of things. So, and I see no reason why not to join the team. It has been fun. The ride has been good. I think that's all. Thank you, everyone.
All right, thank you very much, David Skylight. So go over to the next slide. I'm not sure if Wisdom is with us, but Wisdom is the voice behind the beautiful animation piece that you saw. He's a voiceover artist. I don't think he's on the call. He's not on the call currently. He's the voice behind the portfolio piece. I don't know if you watch the video, you were wondering, is that AI? Is that a Nigerian talking? So that's Wisdom. That's what Wisdom is. A voiceover artist, and he's very good at it. When he speaks with like a foreign accent, which is mesmerizing. So that's why we called him on board to join us, to join our team, and it has been fun. Wisdom is fun to work with. Wisdom is very very kind, but he could not join the call today. and he could not present. I think he was busy. I'll be handing over the mic to, I think I saw, yeah, Oyomi Samuel Oblo is my very, very close friend, my colleague. I would like you to share your experience working with the brand. Yeah, so I'll be muting myself now. Oh, all right. So in that case, so let me just say one or two things about Oblo. Oblo is my very, very close friend. It was one of the first people that I told about this idea. I told you that this idea has been in incubation for as long as I can remember. I've always wanted to combine these two worlds together. I enjoy both worlds. I'm interested in both worlds. So merging the two together, I remember when I was on 100 level, we were very close. When I was on 100 level, I had a lot of issues combining the two. People were saying that it's not easy, but in 300 level, I was able to like break free and I found a clear workable pathway to be able to merge the two worlds. And Oblo has been very, very supportive. Samuel has been very, very supportive. Samuel has been very, very kind. It was one of the first people that I told you about the project, and naturally, he was very, very interested in joining the team. Let me go back to the next slide. Where okay, so I'll be muting myself to. Oh, okay, he's not on the call. He's not on the call. He's not on the call. So this is Lirelua or JJ. He is also a client and relation of talent scouting. He's also in charge of scouting. He could not join us today, and he could not also display slides. But he has been very, very fun to work with. All the late night calls, all the unscheduled calls that we have been hosting, all the after hours, calling in the middle of the night just to plan, just to prepare. So I'm very, very, very grateful for everybody that has been involved in the team. So those are the beautiful faces that are involved in this project. That's everybody. That's all of us. And we appreciate you guys for coming. We appreciate you guys for honoring our invitation. Appreciate you for supporting us thus far. Since for the past 2 months now, we have been working on this project. If you would like to support us, you can head over to our website and check it out. I think it has been open just for this call. It is not fully ready, but I think you guys can check it out. If you have any questions, if you want to reach out, any professional relations, you can send us an email on membranelabs3d@gmail.com. Then this is our website, and this is our WhatsApp number if you want to reach out to us. And these are also our social media pages. So before we call this meeting a close, I'd like to ask if you have any questions. We're asked to drop our questions before. You can kindly drop them here. And if you have any questions like to ask us, you can just unmute yourself also and speak. But if you are shy, you can just drop your questions and we'll get right to it. All right, I'll take that as I'll take that to mean that there are no questions. So I'm just going to quickly say a few words before we call this a close. I appreciate everybody for coming. This has really been a lot. This entire thing, this entire presentation, this entire thing, this entire project, that's been quite a lot. That's been quite a lot. For the past 2 months, ever since we finished our final exam in our final part 3 exam, we call it the medical board exam, we have been working hard to make a difference, to bring this to your view so that you guys can see your something that we're working on. And we are not done yet. We are not done yet. We still have quite a lot cooked up. Still have quite a lot cooked up in our as far as our portfolio is concerned. It's just a matter of sharing them with you. And we would love If you can continue to be a part of our community, your support means a lot to us. And so far, so good. Your support has been very, very, very awesome. Thank you so much. Thank you so much. So, with that, I would like to call a presentation to an end. And don't forget that you can always reach us.
Sorry, I think there's a question in the chat box.
Okay. All right. Let me. All right. Okay. So there's a question from Oluwatomisin Ogunwole. So yeah, it's asking us if there are any platform where we train students who would like to join the team. So what we are doing currently is launching the brand, and trust me, by next year we are going to be open to training. I don't know if Oluwatomisin Ogunwole is still on the call. Okay, so you can reach out to us personally. Maybe you reach out to our WhatsApp number, you drop your own WhatsApp number in the comment section. You can reach out to us. But one thing I want to assure you is that that's also part of our agenda. We are going to create a school, a kind of an academic area for students or scientists that want to be involved in 3D. So it's going to be animation for scientists, something like that. So we are still workshopping that. That's a very, very good question. This is something that we're still workshopping. Currently, we are working on building the brand, and by the end of the year, everything in the brand will be finalized. Everything has been finalized. So thank you very much for joining the call. If there are any other questions, you can feel free to drop them in the comment section, or you unmute yourself and ask. All right. So Tommy, since okay, thank you very much. Thank you very much. So if there are any other questions you would like to. All right, so I'll take that to mean that there are no other questions, but feel free to reach out to us. Feel free to connect with us. All of us that presented today, we're on LinkedIn, our social media also, and the brand Membrane Labs is also on social media. We're on Facebook, we're on Instagram, we're on LinkedIn, we're on YouTube, we are basically everywhere. And we have a lot in store for you. So thank you for joining us. Thank you for being a part of this vision. We are very, very, very grateful. And trust me, this is just a tip of the iceberg. We have more in stock for you. And also, if you're interested in collaborating with us, if you're interested in hiring us, if you're interested in research, whatever the case may be, we would like you to connect with us. So I'm going to be dropping WhatsApp number that you can quickly reach out to. It was on the slide, but I'll drop them on the comment section now, so that if you want to reach out to us, you can just always click the phone number. So I just sent it to the comment box, and I'll take that to mean that there are no other questions. So thank you very much for joining us. We're very, very grateful. And that is the end of the meeting. Thank you. Thanks for making this memorable. We're very, very grateful. And if any of us has any other thing to say on the team, you can always unmute yourself and speak. Thank you very much for joining the call today. We're very, very grateful. Thank you.
Thank you very much. I think we can only become.
All right, thank you so much.
You can all,
thank you. It was really nice.
All right, thank you. So another thing is that the call has been recorded. The call has been recorded. If you would like to maybe go over what we discussed today, the call was recorded. We are going to be uploading the call to our YouTube channel for those that missed the call. So all of you can everybody can go over everything that was discussed again. So we'll be uploading the call, the recorded call to our YouTube channel, and we'll be sending the link to our community. So feel free to reach out, feel free to follow up, feel free to join our community for updates. Thank you very, very much. So I think with that, we can all leave the call now. Thank you.